Hello, researchers, and welcome back. This is part 2 of our lesson on experimental designs. So, what are the types of experimental designs? There are two main types, between group designs and within group or individual designs. There are four between group designs that we're going to talk about: true experiments, quasi experiments, and causal comparative research and factorial designs. And then three within group or individual designs we'll talk about: time series, repeated measure, and single subject. All right, so first, true experiments could be, they include random assignment generally, definitely. And you usually have a random assignment to a control group and an experimental group. You have a pre-test usually, but not always. And then the experimental group gets the experimental treatment, whereas the control group doesn't. And then there's a post-test. Pretty straightforward. Now, quasi experiments are different in that there isn't random assignment. Generally, you have intact groups. And this is common in educational research because generally we're not going to have a group of kids and then randomly assign them to classrooms and then and then assign a classroom to receive a treatment or not receive a treatment. The classrooms already exist, the classes already exist. We're not going to shuffle kids around just so we can do our experiment, right? So we have intact groups. So basically we're going to select who is the control group and select who is the experimental group, but the groups themselves already exist. That's a quasi-experiment. And what is this slide? Okay, I don't know what this slide is. Okay, so I talked about true experiments, slide 27. One thing to add is that the design of true experiments, because you're doing this random assignment, you eliminate many of the threats to internal validity. That is, the threat of some extraneous variable being responsible for what your findings are. Controls include pretest, matching, blocking, and the use of covariates. Quasi-experiments, that main difference is a no random assignment on slide 28. And so you have intact groups. You still have interventions by the researcher though, just like true experiments. Okay. They have there's a greater threat to internal validity. There's a chance that because these are intact groups, there's a chance that some characteristic that was prevalent in one of the groups could have affected your results. Okay. So, causal comparative. No random assignment, two or more groups compared. The difference is between between causal comparative research and experiment, whether it's true experiment or quasi experiment, is that the researcher does not directly intervene. Okay, so sometimes this is called a natural experiment. Something happened that made two places or sets of people different or experiencing different things. So, for example, if we were comparing the achievement of kids in science in McDuffie County to the achievement of kids in Richmond County, let's say. And in McDuffie County, they happen to, let's say originally the two groups the two counties had the same high school science curriculum. But then in McDuffie County, they happened to adopt a new curriculum for their science curriculum in high schools. And then we decide, okay, we're going to compare the effects of, this typical curriculum to this new curriculum. We might compare the science achievement of kids in Richmond County to the kids in McDuffie County, right? We as the researchers did not choose the science curriculum. We did not intervene. These two groups of kids just happen to be receiving different science curricula, and we're going to take advantage of that in order to compare the effectiveness of the curriculum. So we might still do matching, like matching the characteristics of the various classrooms that we're going to compare. We might still use covariates, especially we might want to make sure that we're seeing what the socioeconomic status is of the various kids whose science achievement scores we're going to be comparing. But we did not directly intervene. Now, there are more potential threats to internal validity, or the question of what we say happened, did it actually happen? And because these are both intact groups, and we didn't choose the curriculum. Maybe in the place where there's the new curriculum, the teachers are really energized and excited, and so there's just more energy on the part of the teachers to implement the new curriculum versus the old curriculum. Or maybe the opposite. Maybe they're like, hey, we liked the old curriculum, why is the district doing this to us? And they're less invested, and that might affect your results. So because it wasn't the researcher intervening, and because we don't have random assignment, we have to pay attention to potential threats to our validity. Okay, now factorial designs, this is just a way of saying how, with factorial designs, you can think of it as like little cubes or rectangles, because you have usually more than one thing going on at once. So for example, in the previous case, we were looking at high school students learning science. What if we were interested in gender as well? Okay, so we might have McDuffie County girls, McDuffie County boys, Richmond County girls, Richmond County boys. You see how that's like a little square? And that's why it's called a factorial. It's 2 by 2, a 2 by 2 square design. So it's usually when you're comparing, looking at more than one factor. One factor would have been which science curriculum was used. The other factor is gender in that example. So here is with the smoking example, and this is discussed in your textbook. There's the standard lecture versus the health lecture. And then what if we gave everybody the Beck's depression inventory before they received our lecture? And we might have discovered that some people weren't really depressed. They scored low on the depression inventory. Some people were maybe moderately depressed. They scored medium on the inventory. And some people, it seemed like they were really struggling, and they scored high on the inventory. Okay, we might see if there's an effect of depression on smoking, and we might see if there's an effect of the type of instruction on smoking. And then we might see if the effect of the type of instruction on smoking varies depending on how depressed a person is, right? So maybe a person who scores high on the Beck's depression inventory, so they're feeling pretty depressed, maybe they don't care one way or the other what lecture you give them. They're not feeling good about their life anyway, right? Whereas someone who scores low on depression, they're less depressed, maybe it really matters receiving the health lecture because they're like, oh my goodness, I got to change right away. I'm feeling pretty happy with my life, and I don't want to end up with lungs that look like that. Okay, so and that would be an interaction effect, where the effect of the type of instruction varies depending on how depressed a person is. The type of instruction interacts with the level of depression. Okay, so two factors interacting is something that you can see in a factorial design. Okay, now let's talk about within group designs or individual designs. And this is very common in psychology and mental health because often you're dealing with a particular case. And in psychology, mental health, and counseling, the case is an individual. Okay. In education, the case is often a school or school district is the unit of the case. But in psychology, mental health, and counseling, the case is an individual. So these individual designs are used quite a bit. There are time series experiments and there are repeated measures experiments. So let's look a little more closely at these. So time series designs, basically you are doing something, but you're doing more than one pretest or more than one post-test. Okay? And what this adds is that you all know you give a test to a particular group of kids one day. Well, what if it's homecoming the next day? They may not be focused on your test. Or what if it's the day after Halloween? They may be, hyped up on sugar and not that focused. So if you gave the pretest measure more than once, you might get a more accurate measure of whatever it is that you're trying to assess, right? Let's say you gave the pretest more than once and then you do the intervention and then you do the post-test measure more than once. Okay. So that's kind of like the intervention interrupts this series of tests that you're giving. And easy way to think of this is spelling tests, right? At an elementary school, kids take a spelling test every Friday, let's say. And so you can think of the tests happening on Friday. So you teach spelling the normal way for the first 3 weeks, and then you try something new to get them jazzed up about spelling, and then you teach it the new way for the next 3 weeks, and you see if there's a difference. Okay. Another way you can do it is you can intervene in between the tests. So you select a group, you give their pre-test, then your intervention, and then you get kind of like a post-test, and then another intervention, another post-test, and another intervention, another post-test. And then you can compare each of those measures to one another. There's no random assignment. Okay, the group is the group. The person is the person if it's an individual. There may be 2 or more interventions. Usually one intervention is no intervention. It's the business as usual. And the dependent variable is measured after each intervention. Typical controls include covariates. And most threats to internal validity are minimized because it's the same group of, you're comparing the one group of kids to the same group of kids, right? So whatever they came in with, they still have, right? So whatever characteristics that group has, if it's a classroom, whether it's the number of gifted kids and the number of special ed kids, and so that they have the same characteristics before and after, so you think that your intervention is probably what is responsible for any change. Same thing with an individual, right? We don't expect the individual to change that much it might be helpful to ask if anything, if anything in their life dramatically changed, particularly in counseling, where if there's some dramatic event that changed their level of motivation, that was outside of your intervention, you want to know. But in general, most threats to internal validity are minimized with this type of design. The problem is that you kind of preview what is important to you with the pretest, because and you have to have a pretest. You have to have some kind of baseline since you're comparing people to themselves. Okay, so this next slide just illustrates this repeated measure design. I just kind of illustrated. Oh yeah, yeah. Similar to the time series experimental designs, right? Um, Sometimes there are different ways that these designs are talked about. Single subject designs are talked about. So they might be called ABA, right? Where there's the baseline phase, then something changes, and there's the phase where it's the behavior is occurring under the intervention, and then A, you go back to business as usual, and you do your measures there. Or there may be C, a second phase of the intervention, and usually some kind of target behavior is your outcome. And these kinds of designs, you can imagine that they may be used with students with disabilities, for example, students with autism. If with this particular student, I use a picture, a, a picture schedule where I'm showing, let's say I do my normal thing where I explain to them every morning, here's what we're going to do today, right? For 5 days. And the next 5 days, I show them a pictures of what we're going to do, right? And then the next 5 days, I go back to my normal thing of explaining in the morning what we're going to do. So let's say it's a student who gets upset when you're changing from one thing to the other. That first week, that first 5 days, I'm explaining verbally. I count how many times do they get upset when it's time to transition from one thing to the next. The next 5 days, when I'm showing the pictures, again, I count how many times did they get upset when we were transitioning, and then we go back to the business as usual, and again I count how many times did they get upset when they were transitioning. If I find that they got upset less with the picture schedule, then that gives me information, right? And I'm going to start using that picture schedule every week after that, or every day, to help them with transitions. Okay, and here's a little bit more about, on slide 37, a little bit more about individual designs, and there's more in your textbook. But I want to spend our last bit of time together talking about ethical issues with experimental research. Experimental research is not used that frequently in education. It's considered the so-called gold standard of research designs because the threats to internal validity are minimized. However, there are some potential ethical issues that make experimental research difficult to justify in education. One is you're withholding treatment from individuals. So with this whole idea of a control group and then the comparison group, the treatment group, you're withholding treatment from the control group kids, right? So if you believe that the treatment is going to benefit them, why would you withhold it from a group of kids, right? Just to prove that it works, right? It's only when you're not sure that something is going to be of benefit that it's ethically okay to keep it from keep it from children, right? And so that's one problem. One way that's minimized sometimes is that we say, okay, we believe this is going to be helpful. We're going to withhold it for just a short period of time from the control group. So we believe a particular after school program may be helpful. We're not sure. We have to evaluate it to make sure we're spending our money wisely. So we're going to have one group of kids get the only a select group of kids will get the after school program in August and September, but then starting in October, everyone will have access to it. You know what I mean? And then we can compare data for those who got it to those who didn't get it in August and September, but we're kind of trying to minimize the damage of withholding this potentially beneficial after school program by keeping the time period short, the time of our experiment short. Random assignment may not be ethical. There's a lot that goes into scheduling. I'm sure many of you know. There's a lot that goes into assigning to classes. You can't just put kids in all different places. There's a lot that goes into it. So random assignment. It's important to conclude an experiment when it's when you have the information you need. This was the big problem with the Harvard Tuskegee experiment. They already knew that they had a effective treatment, and they didn't conclude the experiment and say, hey, let's give everybody the treatment now. And so that was tragic and horrible. Now, there's a question of whether an experiment will provide the best answer to a problem. Often, you may not need to do an experiment per se in order to know whether a program is effective or not effective. And also, if the stakes are high, that adds a little bit of difficulty. How much is riding on the success of this experiment, and how is that going to affect the participants in the experiment? And this is something that you see in Grey's Anatomy they explored, right? So it was a medical experiment, but it was like the chief's wife who had the disease. So, of course, our favorite doctor is going to make sure the chief's wife gets the treatment, is in the treatment group, right? And yeah, and so the stakes are high, and that's going to affect whether it feels ethical to actually do it as an experiment, and if it's going to affect the behavior of the people who are participating. Okay, so that's all for our discussion on experiments. Okay, and I hope you have a great rest of your day. Bye-bye.